Hey everyone, welcome back to another episode. Today we're building a fantastic little Python application that utilizes the power of FastAPI alongside a Postgres repository. To ensure our data is nice and clean, we'll be leveraging Pydantic for validation, and for interacting with our database, we'll use PsychoPG. Throughout this episode, I'll be your guide as we set up the project from scratch. We'll then delve into the wonderful world of FastAPI, focusing on the key features that make it perfect for building this kind of application. By the end, you'll have a solid foundation for creating your own fast API apps with Postgres. So, are you ready to dive in? Let's do it. Now, to jump right in, let's open up our project in PyCharm, just like we usually do. Remember, you can also grab the code for this episode from GitHub. The link is conveniently placed in the description below this video. Once you have everything ready, we can start exploring the magic of FastAPI. All right, so to keep things nice and focused, we're going to build a really simple app that only has a single table to manage users. In this section, I'll give you a quick refresher on how we can use Pydantic and PsychoPG to work effectively with Postgres. But if you'd like a deeper dive into that process, definitely check out my previous video where I break it all down step by step. You'll find the link right down in the description below. Now, with that in mind, let's jump into building our user table. All right, let's talk about the structure of our user data. In this simple SQL script, you can see that we'll have a table in Postgres with 4 columns: an ID, a name, a timestamp for when the user was created, and another timestamp to track when any user information is updated. All right, let's talk about how we'll represent our user data in Python. Instead of a single model, we'll actually define 3 separate Pydantic models to handle different scenarios: reading, creating, and updating users. The first model, simply called user, is for reading user information. It acts as a blueprint for the data structure in our user table, with attributes like ID, name, created at, and last updated at. This model helps us understand the format of the data we'll be retrieving from the database. The second model, named user input, is specifically designed for creating new users. This model includes fields for name, but cleverly auto-generates the ID, and created at timestamps using the computed field decorator. This saves us from manually assigning those values in our code whenever we create a new user. Finally, the third model, user update, comes into play when we need to update existing user information. Similar to user input, it includes the name field, but also auto-generates the last updated at timestamp. This ensures our records always reflect the latest changes made to a user's information. All right, now let's take a peek at the SQL templates we defined for our application. We have 4 handy templates that cover the essential CRUD operations: create, read, update, and delete. One cool thing to notice is how we use placeholders within these templates. These placeholders represent the field names from our Pydantic models. This is a neat trick that allows us to write secure SQL statements with PsychoPG and Pydantic. When it's time to execute the queries, we can simply provide the data as key value pairs, making the code clean and less prone to errors. Okay, last but not least, let's dive into the CRUD class. This class acts as the bridge between our Python code and the database. It uses the prepared SQL templates, filling in the placeholders with the actual data. In this tutorial, we create only the 4 basic CRUD operations, corresponding to the 4 templates we have seen before. All right, fantastic. Now that we've built the core functionalities of our application, it's time to tie everything together into a full-fledged FastAPI application. Let's see how we can package these functions into a powerful API. The first crucial step is to define the initial state of our application. This is where the lifespan function comes in. It's an asynchronous function decorated with a context manager. This function plays a vital role because it gets executed automatically when our application starts up. You can utilize this function to perform any essential setup tasks before your app begins processing incoming requests. Inside the function, we use a with statement to open a connection pool to our Postgres database. This ensures the pool is automatically closed when the application stops, just like turning off the lights when you leave. Inside the with block, we yield a dictionary containing the connection pool. This dictionary becomes the initial state of our application, providing access to the database connection pool whenever needed. Before we move on, I wanted to take a moment to talk about connection pooling. Connection pooling is a fantastic approach because it eliminates the inefficiency of constantly opening and closing new database connections for each user request. Imagine it like a waiting room for connections. Your application can quickly grab a ready connection from the pool for each request and then return it when finished. In summary, connection pooling optimizes your app for speed, scalability, and efficient resource management. All right, let's talk about dependencies in our FastAPI application. These are essentially functions that can be injected as arguments into other functions. Imagine you have reusable building blocks of code and dependencies act like those blocks, providing specific functionality. The beauty of dependencies lies in chaining them together. By combining these building blocks, you can create complex and powerful logic for your application. This approach allows you to write clean, efficient code that's easy to understand and maintain. It's like building with modular components. Each dependency plays its role, contributing to the overall functionality of your application. Let's have a look at the dependencies within our FastAPI app. At the very beginning of each dependency chain, we have the request argument. This argument carries the request information. This includes the current state of the app. The first dependency retrieves a connection from our connection pool. The second dependency takes the connection retrieved in the first step and uses it to create an instance of our CRUD class. By cleverly chaining these dependencies, we achieve two key things. First, each function in our application receives a CRUD instance with an active connection to our database, ensuring smooth interaction. Finally, when the request is complete, the connection is automatically closed, just like cleaning up after yourself. This approach keeps our code clean and efficient, while ensuring optimal resource management. All right, now that we've explored dependencies, let's shift gears and talk about the exciting world of routes in our FastAPI application. These routes act as the entry points for users to interact with our API via HTTP requests. Imagine them as pathways leading to specific functionalities within your application. FastAPI provides a powerful tool called the API Router class to help us organize our routes effectively. It's particularly recommended for larger applications with a multitude of routes. This class allows us to group related routes together by topic, making our codebase more structured and easier to navigate. It's like having a well-organized map. Users can easily find the specific functionality they need, and developers can keep the codebase clean and maintainable. Let's dive into the first route of our FastAPI application. We use the post decorator to define that it is a post request. This decorator lets us specify several things. The path, which is here, simply the root of the router. The response model, which will be the newly created user object, and the status code will be set to 201, indicating successful creation of a new resource. The function of the route takes two arguments. The first argument is a CRUD instance, which is injected by the dependency we defined earlier. The second argument is the user input, which is the actual data sent by the user in the request body. FastAPI's handy body function comes into play here. It extracts the data from the request body and automatically converts it into a user input object using the Pydantic data model we defined earlier. This makes it super easy to access and validate the user information. Our next route retrieves user information. It's a GET request, meaning users can access it to fetch specific data. To use this route, you'll need to provide the user ID you want information for within the path itself. Just like the previous route, the response will be a user object containing the requested user's information. The function itself takes again two arguments. The first argument is the injected CRUD instance we already know. The second argument is the ID of the user we want to retrieve information for. FastAPI's fantastic path function swoops in here. It cleverly extracts the user ID from the request path itself, ensuring it's the correct data type. This makes it simple and secure to access the specific user data. The third route is a PUT request, where users can send data to modify existing user information. Similar to the GET route, you'll need to provide the user ID in the path to specify which user's information to update. The response, once again, will be a user object, reflecting the updated user data. This function has three arguments: the injected CRUD instance, the user ID from the path, and the user update object from the body. The fourth and last route is a delete request, where you can delete a user. Again, you'll need to provide a user ID in the path, but this time, we'll just return null. The function here has the injected CRUD instance and the user ID as arguments. These four routes exemplify the essential CRUD operations. In upcoming episodes, we'll dive into building more sophisticated applications. Now that everything's in place, let's launch our application. It's a simple process. We just need to assign our lifespan function to the app. This ensures the connection pool is set up before anything else. Next, we integrate the user router containing all the user routes we defined. This allows users to interact with the app. Finally, we use Uvicorn to run the application. Uvicorn is like the engine that brings everything to life. Once you complete these steps, hit that run button. By default, our application will be up and running on port 8000. Now, let's put our API to the test. Here's how. PyCharm has a built-in HTTP client that's perfect for exploring our API. I've prepared a handy script that guides you through each API request one by one. It's like a step-by-step instruction manual for testing all the functionalities we built. Let's start by sending a POST request to create a new user. You'll see the API automatically generates the user ID and creation timestamp for you. Now let's use a GET request to retrieve the user we just created. This will confirm that the user information is stored correctly. Time to modify some data. Send a PUT request to update the user's name. Notice how the API also updates the last updated timestamp, reflecting the change we made. Finally, let's send a delete request to remove the user from the system. This ensures we clean up after ourselves. By following these steps and using the walkthrough script, you can test each API endpoint and see how it responds. It's a great way to ensure everything is functioning as planned. All right, folks, that's it for this episode. We covered a lot of ground today, from dependencies and connection pooling to routes and user management. It might seem like a lot to absorb at first, but trust me, working with FastAPI hands-on will make things much easier. The more you practice, the more comfortable you'll become. If you found this episode helpful, smash that like button and subscribe for more. We've got plenty of exciting adventures planned in the world of FastAPI, so don't miss out. See you next time.